right? All right, the next one is the vertex. A lot of vertex problems and completing the square coming up. So the student wanted to know how to find the vertex. So a couple different ways we could do this. Just a reminder, guys, the vertex. Let's see, 5. It's probably gonna look something like that. Remember, the vertex goes through this line of symmetry. So remember, the line of symmetry is x equals opposite of b divided by 2 times a. So that's the line of symmetry. Okay, so the vertex lies on the line of symmetry. So one thing you could do is you could find the line of symmetry, which in this case would be x equals -3. And then what you could do is plug in -3 to find the y coordinate. So when you plug in y sub -3, you get -3 squared plus 6 times -3 plus 5. And therefore, that's 9 plus a -18 plus 5. So that becomes a -9 plus 5 is a -4. So therefore, you can say that y is equal to -4. So the vertex is going to be -3, -4. However, a lot of students also are kind of used to completing the square. But I want to do that for the Algebra 1 students. That's kind of one of the ways that we introduce them to finding the vertex. But then once we get a little comfortable with that, we can now work to completing the square. And again, the completing the square is going to be writing this in standard form. Now, I did this last night, so I'm not going to go over this again. But basically, our idea is we want to write a perfect square trinomial with 6. So, with our first two terms, these x squared plus 6x. And actually, this was in my lesson today. So I'm just going to do the general process, the b divided by 2 squared. So I'm going to take my middle term b divided by 2, which is 3, and square it, which is 9. Now, when I add that number 9 into my expression, right, I created a perfect square trinomial. Now, if I add 9 and then subtract 9, right, I should rephrase that. Whenever I add 9, you got to remember this is an equation. You just can't randomly add a 9 to an equation without either adding it to the other side or subtracting it on that same side. But now I can simplify this to x plus 3 quantity squared minus 4. And now you can see, based on the understanding for the vertex in vertex form, you can see the vertex is going to be -3, -4. All right. Now the student did also ask how to find the x and y intercepts. This is also something I think I did last night. So just remember, guys, the x-intercept is when y equals 0. So just plug 0. Or I'm sorry. Yeah. I don't know why that's not working anymore. Got to fix that. It's still y is equal to 0. So set y equal to 0 and then solve for x. Well, now we have a quadratic equal to 0. So we want to look to factor using the zero product property, or you could complete the square, or you could also do the quadratic formula. Thankfully, I chose a problem that was factorable. No, I did. Yeah, I did. Why am I doing a 3? This is really annoying. I got to change these shortcuts. So this would be an x plus 5 times an x plus 1. Okay, because 5 times 1 is 5. 5 plus 1 is 6. If you were to expand that out, you can see you'd get those answers. So my x-intercepts are going, actually, let's just do the 0. Oh, this is really annoying. I'm so used to using my erase keys. And for some reason, they're not working anymore. But now we have a product equal to 0. So we have x plus 5 equals 0 and x plus 1 equals 0. So therefore, solving, I get x equals -5 and x equals -1. Now, if I wanted to find the y-intercept, then I just make x equal to 0. And therefore, I would just have y is equal to, let's see, where is 0? So that'd be 0 squared plus 6 times 0 plus 5. And what you'll notice for polynomials is the y-intercepts just